Okay, so this week we are going to talk about our seventh thing, which is exponent rules. So Unit 9 talks about exponents, and I just think that this first part is really kind of fun. Actually, I think everything in Unit 9 is kind of fun, but then I'm weird. I know teachers are weird. For me, this is going to be pages 12 and 13. I'm going to put exponent rules over here at the top. And then I'm going to put over here the same thing, exponent rules. So this is our only thing this week is 9.1. Remember I was talking about how I had built in some extra time. So again, if you're still finishing Unit 8, which is our Unit 2, the curriculum's Unit 8, keep going. Don't worry about getting it done by the due date. I want you to take your time and learn it, and not rush to get stuff done. So this video will be here whenever you're ready to start Unit 9, right? So our goal, I can never remember what I put on this left-hand side. Our goal is to talk about the exponent rules. And the vocabulary. We're going to cover the vocabulary a little bit too. Did I spell that right? Vocabulary, yeah. And then, like usual, take some COVID notes, right? We're living in a weird time. I'm making you do math in a time when it might not be easy to do math. I am feeling like my brain is not plugged in this week. All this week, I've just felt like I am not firing on all cylinders. So take some notes to yourself about how you're feeling right now. I'll come back and write that in later. And then we're going to take some other notes. So when I say exponent rules and the vocabulary, like, what do you think of? Does it make you think of something from your past? So take some notes about your sort of feelings around exponent rules. And then also give yourself a confidence score, right? So, on a scale of 1 to 10, 1 being, I don't have it yet, and 10 being, I have totally got this. Like, where do you kind of land on, when I say exponent rules? Like, where do you feel like you're kind of starting? So go ahead and fill that part out. And then we'll start over here on our right-hand side. So I'm going to start today by I'm going to kind of draw a line down the middle of my page. And I need 9 boxes. So I'm going to kind of see like, okay, so I'm going to kind of divide, maybe I'll go like this. Just kind of divide it up into 5 different sections. So then if I go there's 2, 3, 4, and 5. It doesn't line up exactly with my lines. But I just kind of need 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9 little spots. And maybe I'll start by like kind of erasing this right here. Because the first thing that I want to talk about is what is an exponent? And I'm sure that you've seen them. You've probably seen them this quarter in WAMAP already. But basically, if I have something that looks like this, with a number on the bottom and then this little number up in the top, this is the exponent. We might also refer to it as the power. I could say that this was 2 to the power of 3. The 2, its official name is the base. The base. And what this means is, it does not mean 2 times 3. That is not what it means. What it means is, I take the base and I write it 3 times, and I multiply that all together. So 2 to the 3rd, we might also say 2 to the power of 3, means that I take 2 and I write it 3 times. So 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So 2 to the 3rd is the same as 8. But what you'll see is that the bigger your base gets, the bigger your answer gets to be. So yeah, 2 to the 3rd is only 8, but 5 to the 3rd is 125. So in just a couple of numbers, we have grown a lot. And this is where you might have heard in this coronavirus time, them talk about exponential growth. This is what they're talking about, are these exponents and the fact that they can make these numbers like explode and just get big really, really fast. So that's what they're talking about. Okay, so you can have a positive exponent, which is like we have up here, right? 2 to the 3rd. And I would say that this was 2 times 2 times 2, which equals 8. I could also have something that looks like that. I could have x to the 3rd. So x to the 3rd means the same thing. It means I take that x, I write it 3 times, and this one is, I wouldn't necessarily have an answer for it, but I think that some of you maybe have seen this in WAMAP if you've done it, in order to cancel things out in like a fraction or something, you need to write them out this way. There's also a negative exponent. And just like positive and negative are opposites, adding and subtracting are opposites, positive and negative exponents are also opposites. And so it looks something like this. 2 to the negative 3. And what it means is the reciprocal, the opposite or the reciprocal, which is such a great math word. Reciprocal. I'm just going to take a 1, draw a line, put 2 to the 3rd underneath of it. So 2 to the negative 3rd, or 2 to the negative 3, to the power of negative 3, equals 1 over 2 to the power of 3, 2 to the positive exponent, which then I know is 2 times 2 times 2, which in this case equals 1/8. So do you see how 8 over 1 is the reciprocal of 1 over 8? I've just found the opposite. If I times 8 times 1/8, they would equal 1. My cats are running around in the background. Sorry about that. So anyway, that's what a negative exponent is. And again, you're going to dive into this more once you get into WAMAP and really get to practice it. There's also the option for a 0 exponent. And it looks just like it sounds, right? 2 to the 0. So these guys are pretty easy to answer. Anything to the 0 power, anything equals 1. So 2 to the 0 equals 1, 4 to the 0 equals 1, 100 to the 0 equals 1, y to the 0 also equals 1. So there's, I could give you an explanation about why this is. I'd have to look it up though, because I don't remember off the top of my head why. It's just one of those things that for me, it was easier to just sort of memorize that this is the case. Anything to the 0 power is going to equal 1. I just accept it and kind of move on. Does that sound good? So these are kind of the types of exponents that you might see. I'm going to get some color in here. So these are kind of the types of exponents. I'm going to just kind of go like this, because now we're really going to get into what are officially the exponent rules, right? If I am adding exponents, so say that I have 2 to the third and I want to add it to 2 to the fourth. And this is actually subtracting also. If I'm trying to add or subtract exponents, they mean different things. So in order for me to do this, I would have to look at them individually, right? So I would have 2 times 2 times 2 plus 2 times 2 times 2 times 2. And I know that 2 to the third equals 8. And I know, 2 times 2 is 4, times 2 is 8, times another 2 is 16. This is the only way that I can deal if I'm adding or subtracting exponents. If I've got 2 things with exponents and an addition or subtraction sign in between. So that means if I have x to the third and I want to add it to x to the fourth, I can't do that. I can't do anything with it. I have to leave it like this. There's no way for me to combine these because I'm adding. Same with x to the third. Let's say that I want to, subtraction. Say that I want to subtract x to the third and x to the fourth. There's no way for me to do that. I would just leave them like this. If it's numbers, I can actually do the math and then figure it out. But the cool thing is, for multiplying, dividing, and a couple of other situations, there are these nifty, cool tricks. So if I'm multiplying things with exponents, so let's say 2 to the third times 2 to the fourth, what this means is 2 times 2 times 2. Hey, everybody get along. My cats are not getting along in the background. This means 2 times 2 times 2 times 2 times 2 times 2 times 2. So it's just all the same thing, right? I'm multiplying all of them. So the trick that I can do is to add the exponents. So if I'm multiplying, I'm really going to add them together. I'm going to take this part out. So I'm going to say 3 plus 4 equals 7. So I can simplify that to be 2 to the 7th. And isn't that what I have right here? 1, 2, 3, 4, 5, 6, 7. Yeah, that's what I have right there is 2 to the 7th. The nice thing about this is I can do it with variables as well. So if I have x to the third and I'm multiplying it by x to the fourth, it's going to be the same thing. I'm going to add that 3 and that 4 together to get x to the 7th. So because I have multiplication in between there and not adding or subtracting, I can combine them. But I have to be multiplying them. If I'm dividing things with exponents, I've got a really cool trick as well. So let's say that I have 2 to the fourth. I'm dividing it by 2 to the third. So if I added the exponents when I was multiplying, if I'm dividing, I subtract the exponents. So that's my hint. So this is going to be 2 to the 4 minus 3, which is going to be 2 to the 1, which is just 2, right? That just equals 2. Where it sometimes gets very interesting, though, what if it was the opposite? I'm going to put this 2 to the 1 equals 2 down below here so I have a little bit more room. What if I had, so here's my other example, 2 to the third minus 2 to the fourth. What's 3 minus 4? Oh yeah, that's -1. Ugh. What do I do with a negative exponent? I'm going to take this and make it 1 over 2 to the 1, or 1/2. See how they all kind of like fit together? It's kind of a weird thing. And again, I can do this with exponents, right? If I have x to the 4th over x to the 3rd, I can have x to the 4 minus 3, which just equals x. I could have x to the 10th over x to the 3rd, which would be 10 minus 3, and would leave me with x to the 7th. So I can use these to simplify variables with exponents as well. 2 special cases, because we've been talking about situations where all of the bases are the same, but what if I have different bases but same exponent? So let's say I have 5 to the 7th and I'm timesing that by 8 to the 7th. I could, of course, do the math for this, right? Or I could just look at this and say, wow, these exponents are the same. And the trick is, it's going to be 5 to the 8, 5 times 8. I knew I said that wrong. So what's 5 times 8? Well, that's 40. And then the 7 is just going to come along on the side. 40 to the 7th, just for your information, is this. So that's hundreds, that's 100,000, that's millions, billions. So it's 163,840,000,000. 40 to the 7th. How wild is that? Another thing that we will see is a power to a power. So you might see something that looks like this. 2 to the 2nd, and then that whole thing to the 3rd. So I could solve this using PEMDAS, right? Using my order of operations. 2 to the 2nd is 4. 4 to the 3rd, 4 times 4 is 16, times another 4 is 64. But I could also multiply the exponents. I could say 2 to the 2 times 3, which is 2 to the 6th, which, if you do that math, comes out to be 64. So again, this is going to be helpful if I have stuff with variables. So if I have x to the 2nd and then that whole thing again to the 3rd, I know that it's going to become x to the 2 minus 3, which is the same as x to the 6th. Woo! This was a lot of information. Again, you are going to dig into this piece by piece throughout WAMAP, but I just wanted you to have like a page of all of the notes in one spot so that you could refer to it as you worked. As always, let me know if you have any questions as you work through 9.1. Don't forget my office hours. That's a great place to ask questions, but if those times don't work for you, just let me know. Either text or send me an email. Hey, I got a question. When can we talk about it? And we can set up a Zoom appointment or a phone call and definitely talk about things. So yeah, good luck with 9.1 and exponent rules. They're really fun.